At 3:20 UTC on August 16, 2026, a powerful magnitude 6.1 earthquake ripped through the New Hebrides subduction zone, striking just 56 kilometers off the coast of Port-Olry on Espiritu Santo Island in Vanuatu. This is not an isolated tremor. This is the same island that was shattered by a devastating M7.3 earthquake just 5 months ago in March. It is the third significant earthquake to hit this region in 2026 alone, following that M7.3 and a M5.2 shallow quake in May. While the shaking was felt by an estimated 145,000 people, nearly half of Vanuatu's entire population, the epicenter sat 188 kilometers deep. This is not a random cluster of seismic events. Something significant is happening along this stretch of the Ring of Fire. Today we are going to break down exactly why this M6.1 struck, what it means for the stress building along the New Hebrides Trench, and whether this is a warning sign for something far larger. No guessing, no dramatizing. Just the facts, the science, and the real stakes for the people living on the edge of one of the fastest moving subduction zones on Earth. If you've ever lived through a major earthquake or watched a region get hit by multiple quakes in a single year, you know the anxiety that builds with every aftershock. Have you ever experienced a sequence of quakes like this? Tell us about it in the comments. We're tracking this seismic sequence in real time. Subscribe now to stay updated on the next tremor, the science behind the shaking, and what it means for the Pacific. The August 16th earthquake was a textbook intermediate depth event. According to the USGS, the rupture occurred at a depth of 188.1 kilometers beneath the surface. That depth is the single most important factor in understanding why this quake did not become a catastrophe. An intermediate depth earthquake originates between roughly 70 and 300 kilometers below the surface. This is deeper than typical shallow quakes, which usually reduces the intensity of surface shaking and damage. The energy from the rupture has to travel through hundreds of kilometers of solid rock before it reaches the people above. By the time it arrives, much of that raw power has been absorbed and scattered. The result is a quake that feels like a long rolling sway rather than a violent destructive jolt. The USGS issued a green alert on its pager system for this event. Pager is the automated system that estimates likely casualties and economic losses within minutes of a quake. It is color-coded from green, meaning minimal impact, to red, meaning severe impact. This event came in at green. The official count of confirmed deaths stands at 0. The count of confirmed injuries also stands at 0. Vanuatu's National Disaster Management Office moved quickly after the quake, issuing a statement that ruled out any tsunami threat. They confirmed no damage reports from the affected areas. The quake struck at 3:20 UTC, which translates to 14:20 local time in Vanuatu. That is the middle of the afternoon when schools are in session and workplaces are fully staffed. The timing could have been far worse. A quake of this magnitude at a shallower depth at a different time of day could have produced a very different outcome. The USGS estimates that roughly 145,000 people felt weak shaking from this event. That is approximately 43% of Vanuatu's total population of 334,000 people. Weak shaking means the quake was noticeable, but it did not cause objects to fall or structures to fail. An additional 8,000 people felt light shaking, which is slightly stronger but still far from damaging. The depth absorbed the energy, turning what could have been a disaster into a countrywide scare. But this quake didn't happen in a vacuum. It is the latest chapter in a story that began 5 months ago. To understand the significance of this week's quake, we have to go back to March 29, 2026. On that day, a massive M7.3 earthquake struck the Penama province on the same island of Espiritu Santo. That event was a completely different animal. The M7.3 was a shallow crustal earthquake, meaning it occurred near the surface, typically under 20 to 30 kilometers deep. Shallow crustal earthquakes tend to cause far more direct shaking damage than deeper quakes of the same magnitude. The March event caused extensive damage to buildings and infrastructure across the province. It injured multiple people and displaced families from their homes. The recovery effort from that quake was still underway when the ground shook again. Then came May 16, 2026. A M5.2 earthquake struck 93 kilometers east of Port Vila, the capital of Vanuatu. This quake was even shallower than the March event, sitting at just 10 kilometers beneath the surface. A 10-kilometer depth means the rupture happened almost directly under the feet of the people above. The M5.2 was felt across the capital region, adding another layer of anxiety to a population already on edge. That quake caused no major damage, but it served as a reminder that the ground beneath Vanuatu never truly rests. Now we have the August 16th M6.1. This is the third significant earthquake of 2026 in this region. 3 quakes of magnitude 5 or greater in a single year, all within a few hundred kilometers of each other. To put the energy of these events into perspective, consider this. The M7.3 from March released roughly 60 times more energy than the M6.1 from August. That is not an exaggeration. The moment magnitude scale, which is the modern standard for measuring earthquake size, is logarithmic. Each full number increase represents approximately 32 times more energy release. A M7.3 is a full 1.2 magnitude units larger than a M6.1. That difference translates to roughly 60 times more energy. The March quake was a monster. The August quake was a reminder that the monster is still there, waiting beneath the surface. 3 major events in 5 months. Coincidence? Or is the Earth telling us something? To answer that, we have to look at the engine driving these quakes, the New Hebrides Trench. Vanuatu sits directly on top of one of the most violent plate boundaries on the planet, the New Hebrides Trench. This is a subduction zone, a place where one of Earth's tectonic plates is forced underneath another. Subduction zones generate the majority of the world's largest earthquakes. The New Hebrides Trench is the deep ocean trench marking where the Australian plate dives beneath the Pacific plate. This is the exact boundary responsible for Vanuatu's earthquakes. What makes this particular subduction zone so dangerous is its speed. The Australian plate is subducting beneath the Pacific plate at a rate of 90 millimeters per year. That is nearly 9 centimeters of movement every single year. This makes it one of the fastest moving subduction zones on Earth. To understand what 90 millimeters per year means at human scale, consider this. Your fingernails grow at roughly 3.5 millimeters per month. The Australian plate is moving into the Earth's mantle at about 3 times that speed, continuously, relentlessly, every single day. Over the course of a decade, that adds up to nearly a full meter of accumulated strain. Over a century, that is almost 10 meters of pent-up pressure. That pressure does not disappear. It builds and builds until the rocks along the fault can no longer hold. When they finally break, they release that stored energy in the form of an earthquake. The faster the plates move, the faster the stress builds, and the more frequently the region experiences significant seismic events. The Vanuatu Arc, the 1,200-kilometer-long island chain that includes Espiritu Santo and Port Vila, sits directly on this subduction zone. The entire arc is a product of this violent tectonic collision. The islands themselves are essentially the tops of underwater mountains pushed up by the subduction process. The volcanoes that dot the arc are fed by the melting plate descending into the mantle. This is a region that was built by earthquakes and volcanic eruptions. It continues to be shaped by them to this day. The historical record shows just how capable this zone is of generating devastating events. In 1999, a magnitude 7.5 earthquake struck near Ambrum Island, triggering a destructive local tsunami that swept through coastal villages. The waves arrived within minutes of the shaking, leaving residents with almost no time to reach higher ground. In February 2021, a magnitude 7.7 earthquake struck at the southeastern end of the New Hebrides Trench. That quake was powerful enough to generate a regional tsunami watch across the South Pacific. Then in December 2024, a magnitude 7.3 earthquake struck near Port Vila, the capital. That quake killed 14 people and caused widespread damage across the city. The ground beneath Port Vila is composed largely of reclaimed land and alluvial soil, materials that amplify shaking rather than absorb it. Buildings on this type of ground sway more violently during an earthquake, increasing the risk of collapse. The December 2024 event is particularly relevant to the current situation. Port Vila was still repairing the damage from that quake when the March 2026 M7.3 struck a different part of the same island chain. The infrastructure across Vanuatu is vulnerable. Many buildings are constructed from unreinforced masonry, which performs poorly under seismic shaking. Roads, bridges, and water systems are fragile and slow to repair. The population of 334,000 people is spread across 65 inhabited islands, making emergency response difficult and slow. When a major quake strikes, help cannot arrive quickly. It has to be organized across vast stretches of open ocean. The historical record also shows a troubling pattern. A magnitude 7.0 or larger earthquake has occurred nearly every year since 1980 somewhere along the Vanuatu Arc. This is not a quiet region. This is a region that experiences major seismic events with a frequency that most of the world cannot comprehend. The residents of Vanuatu live with this reality every single day. They build their lives on the edge of one of the most active geological boundaries on Earth. The question is not whether another major quake will strike. It is when and where and how prepared the people will be when it does. The historical record shows this zone is capable of generating devastating quakes and tsunamis. And with 3 major events already in 2026, the critical question on every seismologist's mind is, what happens next? In the hours following the August 16th quake, Vanuatu's National Disaster Management Office moved quickly, issuing a statement that ruled out a tsunami threat and confirmed no damage reports. This was the right response. The depth of the quake meant the risk was low, but the officials know and the scientists know that this quake did not release all the stress along the fault. It released a small fraction of it. The larger picture is far more complex. Seismologists are now watching for a phenomenon known as stress transfer. When an earthquake occurs, it does not simply release all the built-up pressure in a region. It shifts that pressure to adjacent sections of the fault. Imagine squeezing a water balloon. When you press on one side, the water moves to the other side. The pressure does not disappear. It relocates. Earthquakes work the same way. The M6.1 from August may have relieved some stress at its specific location, but it may have added stress to neighboring segments of the New Hebrides Trench. Those segments are now closer to failure than they were before. Scientists do not yet know whether this stress transfer will trigger another event. They do know that the probability of additional quakes in the region has increased. The explosive potential of this region is directly tied to the extreme convergence rate. At 90 millimeters per year, the Australian plate is diving beneath the Pacific plate faster than almost anywhere else on Earth. This rapid convergence means the fault is constantly being loaded with new stress. It does not wait for centuries to build up energy like some other subduction zones. It builds up that energy in decades, sometimes in years. This is why the region experiences such frequent large earthquakes. The system is running on fast forward. The human stakes here are enormous. The total population of Vanuatu is 334,000 people. That is roughly the population of a mid-sized city like Pittsburgh, Pennsylvania. But those 334,000 people are spread across 65 inhabited islands, many of which are only accessible by boat or small aircraft. When a major earthquake strikes, the logistics of response are staggering. There are no interstate highways here. There are no rapid transit systems. There are small airstrips and open ocean. The December 2024 Port Vila earthquake demonstrated this vulnerability when 14 people lost their lives and the city's infrastructure was severely damaged. The city is still recovering. The buildings that were damaged in that quake are still being repaired. The psychological scars are still fresh. The people of Vanuatu are not strangers to this reality. They have grown up with earthquakes. They know the signs. They know what to do when the ground starts to shake. But knowing what to do and being fully prepared are two different things. Many families live in homes that would not survive a major quake. Many communities lack the resources to build earthquake-resistant structures. The gap between awareness and preparedness is a matter of life and death. Scientists are monitoring this region with a network of seismometers that track every tremor, no matter how small. They are looking for patterns in the data. They are looking for changes in the rate of aftershocks. They are looking for signs that the stress is migrating toward a particular segment of the fault. The data is clear. This is a zone of immense power and immense risk. The question is not if another major quake will hit, but when and where. This brings us to a stark realization about life on the edge of the world. The August 16th M6.1 caused no deaths. It caused no injuries. It caused no damage. On the surface, this is a story of relief, a near miss, a quake that was deep enough to spare the people above. But the M7.3 from March was not so kind. It shattered buildings, injured residents, and displaced families across Panama province. Those families are still living in temporary shelters. Those buildings are still in ruins. The psychological impact of that event is still rippling through the population. The contrast could not be sharper. One quake was a quiet event that faded into the background. The other was a loud, destructive force that changed lives forever. And both of them came from the same fault system, the same subduction zone, the same relentless movement of tectonic plates. The danger is not the event itself. The danger is the silence between events. When the ground is quiet, it is easy to forget that the pressure is still building beneath our feet. It is easy to become complacent. It is easy to postpone repairs and delay preparations. But the Earth does not forget. The plates keep moving at 90 millimeters per year. The stress keeps accumulating. The next major quake is already being built, deep beneath the surface, out of sight and out of mind. The data is already telling us what comes next. The only variable is time. Knowing that a larger earthquake is statistically likely, how do you balance living your life with the need to be prepared for a disaster that could strike at any moment? That is a question every resident of Vanuatu faces every single day. It is a question we should all consider because the forces that shape our planet do not discriminate by borders or boundaries. If you believe in the power of knowledge to save lives, hit that like button and share this video with someone who needs to understand the reality of our planet. We're not here to scare you. We're here to inform you. Subscribe to Earth Dispatch for the science behind the headlines. We'll be watching the New Hebrides Trench so you can stay one step ahead. The seismometer is not a crystal ball, it is a stethoscope. It listens to the planet's circulatory system, tracking the rush of magma, the snap of a fault, the slow grinding exhale of tectonic plates. And what it has recorded in the New Hebrides Trench over the last decade is a pattern that keeps seismologists awake at night. Not because the tremors are violent, most are barely perceptible, but because of their relentless consistency. The Earth is not choosing sides. It is not punishing Vanuatu. It is simply completing a cycle that began millions of years ago when the Australian plate decided to dive beneath the Pacific. That decision is still being enforced. Consider the mathematics of the situation. The plate moves at roughly the speed of a fingernail's growth. Slow, almost poetic, until you multiply that velocity by the width of the fault line. Then you are talking about an immense store of kinetic energy, locked and loaded, waiting for the friction to fail. When it fails catastrophically. The 2021 quake was a release valve. But it was not the main event. Geologists refer to these as foreshocks, though they hate the term because it implies a certainty they cannot yet prove. But the data suggests a troubling trend. The energy released in recent years is only a fraction of what the subduction zone is capable of producing. The deficit is the danger. So what do you do with that information? You could panic, but panic is a poor survival strategy. You could ignore it, but ignorance is a luxury the people of Port Vila cannot afford. Instead, they build differently. They reinforce their schools with steel cross bracing. They hold tsunami drills in the villages where the water line is only 100 meters from the kindergarten. They store water purification tablets in every household, not because they expect the worst, but because they have seen the worst, and they know it is not a matter of if, but when. This is the paradox of living on a fault line. You learn to love the ground beneath your feet even as you suspect it is lying to you. You plant your gardens, you celebrate your festivals, you raise your children, and you do it all while keeping one ear tuned to the low hum of the earth, listening for the moment when that hum turns into a roar. It is a psychological tightrope walk, and the people of Vanuatu walk it with a grace that humbles outsiders. They do not see themselves as victims of geography. They see themselves as stewards of a fragile, beautiful island chain that has been here for millennia and will be here long after we are gone. The rest of the world watches from a distance, scrolling through headlines about a magnitude 7.0 in a place they cannot find on a map. But the lesson of Vanuatu is not confined to the South Pacific. Every city on the planet sits on some kind of geological uncertainty. Tokyo, Los Angeles, Istanbul, Christchurch, all of them are playing the same game, betting that the quiet years will stretch into quiet decades. The Earth does not care about your insurance premiums or your building codes. It cares only about the physics of stress and strain. And yet, there is hope in the data. Because for every earthquake that rattles the New Hebrides Trench, there is a team of researchers who are learning something new. They are mapping the fault lines with sonar and satellite imagery. They are measuring the subtle uplift of the islands, the way the ground swells just before a rupture. They are building early warning systems that can give people 20 seconds of notice before the shaking starts, 20 seconds to get under a table, to turn off the gas, to run to higher ground. 20 seconds is not a lot, but it is enough to save a life. So the next time you feel the ground shift beneath you, whether it is a passing truck or the faint tremor of a distant quake, remember that you are standing on a living planet. It breathes. It moves. It speaks in a language of vibrations and fractures. The question is not whether you will listen. The question is whether you will be ready when it finally raises its voice. The people of Vanuatu are ready. They have no choice. And neither, in the end, do we. The Earth will not wait for our consensus. It will move when it is ready, and our only defense is the knowledge we have gathered, the preparations we have made, and the humility to understand that we are not masters of this world. We are its guests, and the ground beneath our feet is never as solid as we imagine. Stay tuned, stay prepared, and stay curious, because the